Sugars are building blocks in nature. They are energy sources. They can be used as energy sources, but they can also be used structurally. So sugars turn up in cellulose, and sugars turn up in hemicelluloses, and sugars turn up in starch. And in starch, they're used as an energy source, and in cellulose and hemicelluloses, sugars are used structurally. The generic formula for a sugar molecule is that. So all sugars will have a formula of that type. And we have a carbon atom here, and we have a water molecule there. So for that reason, because that's when you analyse them, you get 1 carbon, 2 hydrogens, and 1 oxygen. If you do an analysis, that's why they're called, oops, can't spell, carbohydrates. So we might have C6, H12, O6. So that is a carbohydrate with 6 carbon atoms. So we can draw that out. It's going to take a while to draw this out. One, two, three, 4, 5, 6. So there we have a 6 carbon sugar, which is called a hexose. It just so happens that that is the structural, well, it is the chemical formula, not the structural formula, for glucose. And if we look at these carbons here, we'll see that this carbon is joined to a hydrogen, a hydroxyl, this aldehyde group, and this big lump here. So that has got 4 different things joined onto it. And any carbon that has 4 different things joined onto it, I'm doing this as a 3-dimensional type of structure. I'm not doing it very well either. A, B, C, and D. If A and B and C and D are all different, that is a chiral carbon. And we call these chiral carbon centers. So if we're looking at this molecule here, we have got 1, 2, 3, 4 chiral carbon centers. So I can't draw this in 3 dimensions on a 2-dimensional board, but depending on where these hydroxyls and hydrogens are placed, we get different sugars. So these positions here, these 4 chiral carbon centers in a hexose, will determine the name of the sugar. We also have, we can have a mirror image of that form, which I'm not going to draw, because again, I can't draw something in 3 dimensions. But if we have a mirror image of that molecule, it's got the same name, but it is a mirror image, and we call one form a D form and the other form an L form.